Greetings everybody, and welcome to the video on how to convert an absolute value equation into a multi-rule function. And what I've drawn here is actually the graph of the equation y. Let me fix that y, I don't like it. Okay, of the equation y equals the absolute value of x. And we're going to use this as a basic example to kind of give us a guide on how we put this together. Now I want you to notice something here in red. As we start here at 0 and work our way this way in the x domain, or we say x for the values x greater than or equal to 0, we have this portion of the curve. Well, this portion of the curve, notice, has a slope of 1 and an x-intercept of 0. So we could actually write the equation of this particular line as y equals x. Okay, that's pretty straightforward. Now, on the other hand, if we start here and go towards negative x, in other words, x less than 0, okay, in the zone x less than 0, in other words, when we have negative x values, I want you to notice our equation again. Here, the slope is what? That's right, the slope is -1. Notice the rise is still up, but the run is in the negative direction, so we have a -1 slope going on here. So in this case, we still have a y-intercept of 0, so we have the equation y equals -x. Okay, so we can break this absolute value into two separate portions. Now what we do is we're able to write that as a multi-rule function instead of an absolute value. And in calculus, it's going to be an important skill to do this, because we cannot take the derivative of an absolute value. We can't necessarily integrate the absolute value and other types of calculus-based operations. So we have to be able to break the absolute value apart into its separate pieces. So we're going to create a rule for this and a rule for this, and it's simply based on what we wrote here in blue and on the domains we wrote here. Okay, so what we're going to say is our new function f of x is equal to, well, this portion for the positive slope of x. You notice the function has a positive slope of x when x is greater than or equal to 0. So we write x greater than or equal to 0. And then it has a negative slope or negative equation when x is less than 0. And that's what the multi-rule function actually is. And that's really not that bad, okay? But most of the time our absolute values are not done graphically. They're written in a form of an equation, and that's really the purpose of this video, is to show you 3 different examples of how to turn this into a multi-rule function. Okay, and the way I've done it always is the first thing I do is I determine the what I call the break point. Alright, in other words, what is the x value of the v? You'll notice here we have a v. The x value of the v, the tip of the v here, is 0, so that would have been the break point for this problem. In this problem, the break point is whatever makes this equal to 0. So in other words, we find the break point by saying x minus 5 equals 0. And therefore x equals 5 is the break point of the graph. It's where the v occurs. So what I do next is I test the number line. I'm going to put this guy on a number line, and I put the break point in the middle. Okay, just like that. I don't like that 5 the way I drew it, so I'm going to redraw. Okay, so we put the 5 in the middle, and then we test values on the number line. Okay, what I want to do is, if I take a value bigger than 5 and put it into here without the absolute value bars, what kind of number would come out? Okay, if I put 6 in here, for instance, I will get a positive number. So I put a positive sign here. Okay, now if I take a number less than 5, all right, the less than 5 number and plug it in like 4, the internal component of the absolute value, if I do 4 minus 5, I actually would get a negative number. Okay, so that's something we have to consider here. So in the region x greater than or equal to 5, we are going to have a positive function, and in the region x less than 5, we're going to have a negative function. All right, and if you're wondering, why or equal to here and not here, it doesn't matter where you have the or equal to. We just don't put them necessarily on both. Okay, so you could put the or equal to here and leave this one greater than. It doesn't really matter. Standard is not to put it on both. Okay, so now what we do is we build the multi-rule function. Okay, we say f of x equals the negative version we notice here is in this domain. So you say the negative version of the argument, comma, for x less than 5. So basically you take the negative sign, put it in front of this with this assigned domain. Okay? And then the positive version, well, we don't really write the positive sign. We just do that, comma, for x greater, not less than, sorry about that, for x greater than or equal to 5. Okay, so to sum up again, what we do is we find the breakpoint like we did. We found that by setting the argument of the absolute value equal to 0, and we say the answer, then the breakpoint in this case was 5. We put it on a number line and tested values by picking numbers and plugging it into the argument. If the argument's positive, we put a positive sign in that zone. If the argument's negative, we put a negative sign in that zone. And then we write the multi-rule according to the domain. Okay, in the x less than 5 domain, we say negative the argument. And then the x greater than or equal to 5 domain, we say x minus 5, just the positive version of the argument. Okay, and remember, what I'm calling the argument is this section here, the argument of the function. Okay, now let's try another one. Y equals x plus 4. Once again, we find the breakpoint by setting the argument equal to 0, taking this and setting it equal to 0. And we get x equals negative 4. Negative 4. Okay? And we put that on our number line. We put negative 4 on our number line, and we test values in the argument. So what is a number greater than negative 4? 0, 4, 3, any number greater than negative 4, any number bigger than negative 4. So we're going to put 0 in here, and notice it is positive. And then I take a number like negative 5 and put it in here. Well, that is negative in that zone. Okay, so then I indicate my domains. This is x greater than or equal to negative 4, and this is x less than negative 4. And with that information from the number line, I can now set up my multi-rule function, like so. Okay, this domain, we put the negative sign in front of the argument. And you don't have to distribute if you don't want to. Comma, x less than negative 4, because that's the negative zone. And the positive zone, x plus 4, for x greater than or equal to negative 4, like so. Okay? Well, let's do one more just for extra practice. And I want to look at this guy. This is a little different. Once again, remember the argument is the internal part of the absolute value. So I'm going to set 5 minus x equal to 0. And we get x equals 5 as our breakpoint. So let's take a look at our number line now and see if it's any different because of the way it's set up. We put the 5 here. And now I'm going to test the value over in this region, in the x greater than or equal to 5 region. So I pick a number like 6, 7, 8, 9, 10, 100 million if I want, and I plug it in here. So 5 minus 6 is negative. So actually this time, this side gets the negative. And then of course I have the x less than 5 zone, and I put a 4 in, and obviously it's going to be positive. So notice that in this example, the signs got switched. And that's why we test, to make sure of what the signs are going to be. Okay? That's why I will always say test the number line with this type of problem. Now some of these get really complex, can get complex in calculus, and you really have to be careful with your number line. But for now, these types of examples are what I want you to understand. Alright, so in the negative zone, in the x less than 5 zone, we say 5 minus x, comma, x is less than 5. Okay, and then negative this time, 5 minus x, for the zone x greater than 5. All right, and that's our video for today. If you have questions, we'll answer them again in class. Review this a couple times if you need to. Make sure you took good notes on it, and we will see you in class.